Okay, good afternoon. So let us we'll continue last problem. So I think we have covered total 6 steps. So design of roof truss problem we have started. So we will continue with the step number 7, design of roof truss. So step number 7 is the calculate dead load. So basic terminologies we have calculated up to step number 6, and the step number 7 is the calculation of the dead load. Now we have to calculate dead load. So there are 4 types of dead load coming on the roof truss, and that we have to consider while design the roof truss. Now, so first load we have to consider as per the procedure, that is the weight of truss. Weight of truss. So actually we can calculate weight of truss by using the formula, that is the span by 3 plus 5 into 10, 5 into 10 Newton per meter square. But weight of truss directly given in the problem statement. So if you see the problem statement, then you can see the weight of truss is given. So how much weight of truss is given in the problem statement? I think 100 Newton per meter square is the weight of truss is given. 100 Newton per meter square. So first we will see, we will write 4 types of weight, then we will add and we will multiply with the plan area. Then second weight of truss, sorry, second type of load, dead load, is the weight of AC sheet or weight of sheet. So which type of sheet is given in the problem statement? Weight of AC sheet is given. So weight of AC sheet is equal to, please read the problem statement. Which type of load is given? Weight of AC sheet. So weight of AC sheet 160 Newton per meter square is given. 160 Newton per meter square. Then third type of dead load is the weight of purlin. Weight of purlin. So weight of purlin is again given in the problem statement, that is Newton per 100 Newton per meter square. Now weight of bracing is not given. Yes, Gaurav, you are saying 6 step is remaining. Uh, are there anyone can tell me? We have covered, I think, 6 steps total. What is 6 step? I think 6 step we have covered it. Inclined length of one panel. So inclined length of one panel we have calculated. Last lecture we have calculated this, completed step number 6. Gaurav, please verify. At the time of closing the last lecture, we have covered this step number, inclined length of one panel. Okay, so these three loads are given: weight of truss, weight of AC sheet, and weight of purlin is given in the problem statement. Um, so now the fourth dead load is the weight of bracing. So actually weight of bracing is not given in the problem statement. So you can assume or you can take addition of these three loads, because weight of bracing is not given, so we cannot add this weight of bracing. Are you getting? So in the problem statement only these three loads are given. Only these three dead loads are given. So as per the procedure, A plus B plus C plus D, So D load is the weight of bracing. So in the problem statement, they have not given weight of bracing, so we cannot add this. If they have not given any load, then we can add or we can take. If they told, जर त्यांनी सांगितलं weight of bracing घ्या तरच घ्यायचं, otherwise नाही घेतलं तरी चालेल. So in the problem statement, they have given only these three loads, dead loads. So this fourth load, weight of bracing, is not given. So weight of bracing is not given, so we cannot add this. Are you getting? दिलं नाही तर घ्यायचं नाही, आणि जर कुठलाच लोड दिला नसेल आणि तुम्हाला घ्यायचं असेल तर घेऊ शकता. सो टोटल load is equal to so addition of these three. So addition of these three is 360 Newton per meter square. So this is the total dead load, 360 Newton per meter square. But dead load we have to calculate it in Newton. So total dead load in Newton is equal to total load in Newton per meter square multiply by plan area of roof truss. Plan area of roof truss. See, in the procedure, I have written here, every load I have written multiply by plan area of roof truss, plan area. So here what I have did, पहिल्यांदा मी काय केलं, सगळ्या लोडची ऍडिशन केली आणि एकदाच प्लान एरिया ऑफ रूफ ट्रस न मल्टिप्लाय केलं शेवटी. आणि प्रोसिजर मध्ये मी लिहून काय दिलंय, प्रत्येकाला प्लान एरिया ऑफ रूफ ट्रस न मल्टिप्लाय केलंय. इफ यू सी द प्रोसिजर, in the procedure I have multiplied by each dead load multiplied by plan area of roof truss. So instead of each, प्रत्येकाला मल्टिप्लाय करण्यापेक्षा आपण डायरेक्टली टोटल लोडला जर प्लान एरिया ऑफ रूफ ट्रस मल्टिप्लाय केलं तरी काय हरकत नाही. ओके, सो नाव total load. So total load is 360. Total load is in Newton per meter square is 360 into now plan area of roof truss. How to calculate plan area of roof truss? Span by 2, as I told you, span by 2 into spacing of roof truss. So it is given in the procedure, spacing of roof truss. Okay, so is this correct? No, 360 is our answer. 360 is the total load. Sonali, 360 is the total load, that is not given. So 360 is the total dead load. So total dead load is Newton per meter square. So we have to multiply by now plan area of the roof truss. So actually this is the your half roof truss. So this distance is span by 2 and this is the your spacing of truss. This distance is the spacing of truss. So this area is required. Okay, so now Okay. So now 360 into span. How much span is given? 10 by 2 into spacing of roof truss is how much? Spacing of roof sorry. Spacing of roof truss is, I think, 4 meter is given in the problem statement. So 4 meter. So this term is Newton per meter square, and this is Newton meter square. So meter get square get cancelled. So how much answer is in Newton? Just a minute. Tell me answer. So we have to do one correction here, please. Here we have written plan area. So this is the inclined area. Whatever we have written this area, span by 2 into spacing of roof truss. Span by 2 is this distance. But correct. Sorry. Huh. How much answer? I think I have taken this length. How much answer? 7200. 7200 kilonewton. Correct. 7200 Newton is the total dead load. Okay. So now, so this is the total dead load. Now we have to calculate dead load on intermediate panel points. Now, so we have used the Pratt truss. So in the Pratt truss, how many panels we have choose? I think 4 panels we have taken. Okay. So like this we have. So now we have to calculate the dead load on, as per the procedure, dead load on each intermediate panel point. Now this 7,200 kilonewton, 7,200 हा लोड टोटल या पूर्ण एरियावरचा आहे. Are you getting? So this is the whole area where dead load is acting, this 7,200. But now we have to calculate the dead load on each intermediate panel point. It means the dead load on these particular panel points. So these are the panel points. So how much dead load is acting on this panel point? Because like these purlins are provided. So this is the sheet area. And so finally dead load is coming to these points where supports are there. So on these supports, the dead load is coming. So the total area load is coming to these panel points on these panel points. So now we have to calculate how much load coming on these panel points. So these all are the panel points where your AC or GICT is resting. तुमचा जो काय पत्रा आहे याच्यावरचा ट्रसवरचा, तो पत्रा कशावरती रेस्ट आहे? या पर्लिनवरती रेस्ट आहे, हॉरिझॉन्टल पर्लिन. हे पर्लिन कशावरती रेस्ट आहे? तर या ट्रसवरती आहे. हे ट्रसचे हे झाले पॅनल पॉइंट तुमचे. तर या प्रत्येक पॅनल पॉइंट वरती किती लोड आहे दॅट वी हॅव टू कॅल्क्युलेट. सो dead load on each intermediate panel point. So these are all are the intermediate panel points. These all are the intermediate panel points, and these are the end panel points. These are the end panel points. Are you getting? So intermediate and end panel point. So total dead load on each intermediate panel point is equal to total dead load in Newton divided by number of panels. So total dead load is 7200 divided by how many number of panels we have selected? I think 4. Okay. So 4 number of panels we have decided. So calculate dead load on this particular panel point. How much? 1800 Newton. So similarly, dead load on each end panel point. Dead load on each end panel point. So dead load on each panel point is equal to dead load on each intermediate panel point divided by 2. So dead load on intermediate panel point is 1800 divided by 2. So dead load on end panel point is 900. So 900 Newton. So this is the dead load calculation, and we have to show the sketch. After the dead load calculation, we have to show the sketch. This dead load calculation we have to show by sketch. So Pratt truss, this is the rise 1, 2, 3 and 4 panel. Similarly, again 1, 2, 3 and 4. So these are the 1, 2, 3. So here 5 panels are there. 1, 2, okay, now 1, 2, 3. So now 4 panels are there, and these are the panel points. ऍक्च्युली इथं रीज लाईनच्या या बाजूला एक आणि या बाजूला एक आपण पॅनल बसवत असतो, म्हणजे पर्लिन बसवत असतो. रीजच्या या बाजूला एक आणि या बाजूला एक. सो नाव dead load is acting vertically downward. Dead load is acting vertically downward. So we have to show dead load. Now dead load on intermediate panel point. I have told you these intermediate points are the intermediate panel points. So here 1800 Newton, here again 1800 Newton, again here 1800 Newton. This is end panel point. So here 900 Newton. This is again end panel point 900, 900. Here 1800 Newton, again 1800 Newton, 1800 and 900. So this is the your dead load. So this is the truss you are designing, and on this truss this dead load is coming, this much dead load is coming. So 108 one 1800 Newton is the dead load coming on the intermediate panel point, and 900 Newton dead load is coming on the end panel point. So in this way you have to show the sketch of the dead load. Are you getting how we have calculated the dead load? So now next type of load is the live load. Please everyone draw this and show the dead load calculation. So symmetric, we have calculated dead load calculation. We have done the dead load calculation for half part. So symmetric part is there, symmetric truss is there. So next half part same dead load is there. कारण का आपण स्पॅन बाय 2 टोटल स्पॅन इज देअर, स्पॅन बाय 2 आपण घेतला एरिया, स्पॅन बाय 2 मीन्स फॉर दिस ओनली half part. So same reflection of these loads to the next side also. Or now next step number 8. So step number 8 is calculate live load. Calculate live load. So live load we have to calculate. So live load is equal to W is equal to, what is formula? 750 minus theta minus 10 into 20 Newton per meter square. This is the formula for calculation of live load. So now here we have to put the value of theta only. So we have calculated the value of theta. Theta is nothing but the slope. So 750 minus, how much slope is there? I think in the step number 3 we have calculated the slope, 3 or 4. 4 maybe. So how much theta we have calculated? So theta is 26.56. Okay. So 26.56 minus 10 into 20 Newton per meter square. So how much live load in Newton per meter square? So do the calculations. So 418.8. 418.8 Newton per meter square. So here I have to tell you, one question is coming to your MCQ examination. Minimum live load we are considering for the roof truss is 400 Newton per meter square. Minimum we have to consider this much load. Please write down this, very IMP question is there. Minimum live load 400 Newton per meter square we can consider as per the IS 800 2007. In the IS 800 2007 they have given minimum so or IS 875 part 2. IS 875 part 2. This part 2 is for live load. So in this IS 875 part 2, they have given one sentence, minimum live load 400 Newton per mm square we have to consider. So here greater is there, no problem. Whatever greater is there, that value we have to consider. But minimum this value we have to consider, and this value, this is the very important for the MCQ examination. Maybe here 2 MCQ you will ask. This is the which IS code is used for the live load. So which IS code is used? IS 875 part 2. IS 875 part 2 is for live load, and as per this IS code, the minimum live load is 400 Newton per meter square. So this is a very important for the MCQ examination. And again this formula is also very important. So as I told you, this 750 value and 150 value that I have given in the design procedure. So this is very important. Please write down this. These two different MCQs are there, maybe asked in examination. Okay. So now this is live load in Newton per meter square. Now we have to calculate live load in Newton. So total live load in Newton is equal to live load in Newton per meter square into plan area of truss So total live load is 418.8 into plan area of truss, again span by 2 into spacing of truss. So I have shown you plan area of truss in the dead load calculation. So now directly you can put the values into span 10 by 2 into spacing of truss is 4 meter. So calculate total live load in Newton. No. How much calculation? Eight three seven six Newton. 8376 Newton. Correct. 8376 Newton. This is the total live load coming on the our roof truss. Now again, similar to dead load calculation, we have to calculate live load on each intermediate panel point is equal to total live load in Newton divided by number of panels. So how many number of panels we have assumed? So this is 8376 divided by number of panels are 4. So total live load on each intermediate panel point. How much? 2094 Newton. 2094 Newton. Correct. Others, please. Is this correct? 2094. I got only one answer from chat box. Okay, correct. 2094. Now we have to calculate live load on each end panel point. Live load on each end panel point is equal to live load on each intermediate panel point divided by 2. So live load on each intermediate panel point is 2094 divided by 2. So how much this? I think 1047. Correct? 1047. So this is the live load calculation. So now draw the sketch again. So this is the our truss. Now show the loads. So this is 2094 Newton, again 2094 Newton, this is 2094 Newton. So this is end panel, so 1047 Newton, again this is 1047, 1047, this is 2094, this is 2094, and again last end panel point 1047 Newton. So this is the live load calculation. So in this way, the live load is acting on the our truss. And so due to this live load, we can find the forces on this member. So due to this live load, so we can find the tensile force or compressive force on each member. And for this tensile and compressive force, we can design this each members and we can provide the angle section here. Okay, so draw the sketch. Okay, now next step is the wind load calculation. Step number 9. Calculate wind load. Calculate wind load. Now this is a very important and major load on the roof truss. So first we have to calculate basic wind velocity. Basic wind velocity, or we can say speed in meter per second. Okay, so now how to calculate this basic wind velocity, that is VB, basic wind velocity VB is equal to in meter per second. So how to calculate? So for that what we have to do? So this depends on the basic wind velocity depends on the your building where to be located. So now in the problem statement, if you read the problem statement, in the problem statement, they have given our building is located in New Delhi. So for the New Delhi, we have to find out the basic wind velocity, how much the basic wind velocity. So for that, you have to go on the page number, as I told you, page number 125 in the steel table. So anybody having this? Just minute. In the IS 875 part 3, they have given. So I will put it on the WhatsApp. Please, I will put image on the WhatsApp. Please open your WhatsApp. I have sent images, one image from the IS 875 part 3. They are given for each city. They have given basic wind speed. So just minute. Okay. Now everyone can see. I have sent on your WhatsApp group. For Delhi, it is visible properly. See, for Delhi city, how much basic wind speed is given? 47, correct. So here 47 meter per second is a basic wind velocity or wind speed in Delhi. 47 meter per second. So this is the our first unknown we have calculated. Then second, design wind speed. Then we have to calculate design wind speed. So design wind speed is the Vz. So how to calculate Vz? So K1 into K2 into K3 into Vb. Design wind speed, how to calculate Vz? So Vz is equal to K1 into K2 into K3 into Vb. So K1, K2, K3 values are given in the our problem statement. So what is value of K1? So K1 value they have given is 1 only. Okay, 1. K2 value is, I think, 0.88 is given. Then K3 value is again 1 is given, and VB we have selected for Delhi is a 47. So now calculate VZ. Calculate VZ. 41.36. So 41.36. This is again wind speed. So again this unit is meter per second, because K1, K2, K3 are the factors, and again if VB is the velocity or speed basic. So meter per second is unit. So VZ is the 41.36 meter per second. Now next is the design wind pressure. Design wind pressure we have to calculate. So sorry, design wind pressure is the PD. So PD how to calculate? 0.6 Vz square. So this is again very important for MCQ examination. This formula is for MCQ examination. PD is equal to, PD is nothing but design wind pressure, and it is a 0.6 Vz square. So 0.6 into Vz is 41.36 square. So how much? This is a in Newton per meter square, because this is a pressure. So 126.39 Newton per meter square is the wind pressure. It means on the per meter square area 1026 kilonewton, sorry, Newton force will be act by wind. 1026.39 Newton per meter square. It means what? In on the 1 meter square area, this on this 1 meter square area 1026.29 Newton force will be act by this 1 meter square area by the wind. Okay, so this is the wind speed or wind pressure. Okay, so now, okay, so now next we have to calculate small d is the height to width ratio. Height to width ratio. Height to width ratio. So height to width ratio is nothing but h by w. So height of building is given in the problem statement. Height of building is given. I think not given. So here we have to assume. If any data is not given and it is required, we have to assume. Assume height of building. Height of building is 10 meter. Assume height of building is 10 meter. So h by w, it means 10 by w. W is the span of your truss. So total span is again 10. So its value is 1. 10 by 10 value is 1. Now for this we have to calculate the wind coefficients for this and your wind angle. So now everyone please write down. Now write down. Everyone please write down. From page number 16, from page number 16, IS 875 part 3. Now page number 16, whatever page I have sent down WhatsApp to you, this page is required. This page number is 16, IS 875 part 3, 1987. Write down. Choose for external wind coefficient. External wind coefficient. this IS code and page number we require. Now, uh, now you can go on the this WhatsApp. I have sent one page on the WhatsApp before they were start the lecture. So this one value, if we see the page number, H by W ratio, this one value in which condition is there, you can see. Go to page number, this WhatsApp page, whatever I have, minimize the our screen and go to this WhatsApp page. This one value H by W, here they are given in this table at left corner. Three rows are there. First row is H by W value is less than or equal to 1 half. So second row is 1 half is less than H by W, and H by W is less than or equal to 3 by 2. And you can see third is 3 by 2 is less than H by W, and H by W is less than 6. Now our this one value is coming in which category? 3 कॅटेगरी दिलेली आहेत. आपली H by W व्हॅल्यू कुठल्या कॅटेगरीत येते? सेकंड, करेक्ट. Others please, this is very important here. Our H by W value is coming second category. So we have to select the windward and leeward coefficients on the second row. मधल्या रो मध्ये आपल्याला फाइंड आउट करायचे, त्याच्यासाठी H by W इम्पॉर्टंट आहे. अलग लक्षात. others please tell me our H by value H by W value is coming in which category or which row? First row, second row. First means where building is given. आपल्याला बिल्डिंगचा फोटो दाखवलाय बघा तिथं. Are you getting? In second. Now come to this our page. Come to my screen. So here I have written this condition. H by W less than 1 half. Half is less than H by W, and H by W is less than or equal to 3 by 2, and 3 by 2 is less than H by W, and H by W is less than 6. So in that our condition is this. म्हणजे आपली H by W ची व्हॅल्यू इज H by W ची व्हॅल्यू 0.5 पेक्षा जास्त आणि 1.5 पेक्षा, बरोबर. 3 by 2 म्हणजे किती? 1.5 पेक्षा जास्त आहे आणि आपली व्हॅल्यू 1 आलेली आहे. सो फॉर इन दिस रो. त्याच्यानंतर पुढचा रो कोणता आहे बघा? पुढचा कॉलम रूफ अँगल दिलेला आहे. सो देअर दे हॅव गिवन, सी हिअर आय एम रायटिंग नाव H by W ratio. Our H by W ratio is then theta is given, then wind angle 90 degree, then wind angle, this table here I am writing 0 degree. So now we have to find the coefficients. So windward, leeward, again here windward, leeward. So 90 degree, 0 degree. So in second, third मध्ये, फोर्थ मध्ये 90 डिग्री आहे आणि थर्ड मध्ये 0 डिग्री आहे. मग मी अगोदर इकडे 90 लिहिलेला आहे, इकडे 0 लिहिलेला आहे. आता थिटा, सी अगेन गो टू दिस पेज. मी व्हॉट्सअप पेज सेंड केले, त्याच्यावरती जाऊ. आणखी थीटा दिलेला आहे. सो आपला थीटा किती आलेला आहे हो? आवर थीटा इज इक्वल टू 26.56 डिग्री. सो इट इज बिटवीन 20 अँड 30. बरोबर आहे. मग 20 साठी विंडवर्डचा कोइफिशियंट फाइंड आउट करायचा आहे. बघा 20 साठी विंडवर्डचा कोइफिशियंट मधल्या रो मध्ये किती आहे? 90 डिग्री साठी -0.8 आणि 30 साठी अगेन -0.8. तोच लीवर्ड साठी -0.6 आणि -0.8. So now we have to calculate these values. Similarly, for 0 degree angle, जसं आपण लॅम्बडा आणि एफसीडीच्या व्हॅल्यू बघा फाइंड केल्या होत्या, सेम तीच स्ट्रॅटेजी आहे इथे. फक्त 90 डिग्री आणि 0 डिग्री साठी विंडवर्ड आणि विंडवर्ड लीवर्ड साईडला. तर आता 0 डिग्री साठी वरती दिलेला आहे त्या पेज वरती 0 डिग्री. दिस इज -0.7 -0.2. लीवर्ड -0.5 -0.5. So minus indicate your roof is lifting. Means external असा फोर्स डाउनवर्ड येण्यापेक्षा इंटरनल आणि एक्सटर्नल फोर्समुळे तुमचं रूफ लिफ्ट होत आहे. लिफ्टिंग फोर्स ऍक्ट होत आहे. सो दॅट्स वाय दिस मायनस साइन्स आर देअर. अँड नाउ वी हॅव टू फाइंड आउट दिस क्वेश्चन मार्क फॉर दिस थीटा. मीन्स इंटरपोलेशन करायचं आपल्याला आता, आणि ते फॉर्म्युला आपण लिहिलेलं आहे. आर यू गेटिंग? So now this is we have to find out from this table. Please everyone got it? Whatever I am written here, this is from this IS 875 part 3, page number 60. For our condition, H by W condition and theta. H by W and theta, these two are the here known values to us. And from this, we have to find out the windward coefficient and leeward coefficient for 90 degree and 0 degree. Everyone got it this? WhatsApp वर सेंड केलेल्या पेज वरती आहे, ते पेज 16 आहे. So for that, if theory examination is there, so you have to print this IS code also. IS 875 part 3. का मोठा नाही आहे, 15-20 ते 25 पानाचा IS कोड आहे हा. Are you getting now? Whatever I have written here, this is from the H by W value and theta value. And for our theta, now we have to calculate this windward and leeward coefficients. Now we have to follow the procedure. Okay. So what procedure we have to follow? So we have to write here one sentence. Write down as we have written. Write down, let us assume building to have normal permeability. Let us assume to have building to have normal permeability. So for such condition, small a internal wind coefficient. Internal wind coefficient is equal to plus minus 0.2 p. External हे आहेत. These are the external and this is the internal. And B, external wind coefficients. So external wind coefficients we have written already, we have written here. So here we have written external wind coefficient and this is the internal wind coefficients. Now we have to calculate this external wind coefficients for this theta. I think our time is about to close. So tomorrow morning at 10 our lecture will be there. So we will see the remaining part of this wind load calculation in tomorrow morning. But wait, I'm taking attendance now. So this external wind coefficients we will calculate. It means we have to calculate this question marks. 4 question marks we have to calculate. So we will calculate these 4 question marks in the tomorrow lecture. That is the external wind coefficient, and we will find the pressure. Okay. So today we will stop here. And tomorrow morning, everyone please join tomorrow at 10. Okay.